Oh no, I've overslept. This room was so comfortable all night. I wonder how that happened. I was sleeping better than ever. Now I've got to hurry. I'm going to be late for today's Dare to Compare tour. Hey, how long have you been in here? Why didn't you wake me up? You're going to have to leave right now.
Are you Bill?
Are you Mark?
Correct, and I'm late. Sorry about that.
Happens all the time.
My hotel room was so comfortable last night, and I nearly slept through my alarm this morning.
Let me guess. You had an Amana Ptac at your room.
That's right, I think I did. But, you know, I have to ask, what is a PTAC?
Packaged Terminal Air Conditioner.
And that's the subject of our Dare to Compare tour today, PTACs, or Packaged Terminal Air Conditioners. And although you've already met him, let me officially introduce you to Bill Miller, Vice President Manufacturing. Bill, this place is amazing, and it was easy to find as I was rushing to get here today because I was late. And I believe that Amana brand PTACs have been assembled in this facility for over 30 years. Is that correct?
That's absolutely correct, and we're proud of it.
Well, I'll tell you, that's 30 years. That's quite an accomplishment. And everything is assembled in this building. I mean, it all happens right here?
You're going to see it from start to finish. We make a lot of the components and assemble the complete unit.
Well, I can't wait. Let's start the tour.
Okay, I've got your safety gear here.
Excellent.
Let's get rolling.
Here we go. So this is where the birth of a PTAC occurs, huh?
That's right. This is the beginning of the assembly line where we build our packaged terminal air conditioners. Our competitive advantage is the fact that we do assemble this product in the United States. We can build any style a customer wants, short lead times, anything you want.
Well, hey, let's take a look at the line.
One of the other keys to being competitive is the whole concept of lean manufacturing.
Right.
Lean manufacturing is elimination of waste. You notice what this operator is doing. He's building the shipping base pan. That's what we build the PTAC in. And if you think about it, we build it in the shipping base pan. When the PTAC's complete, gets to the end of the line, we don't have to transfer it into the base pan. It's already there.
Right, you're saving steps.
Saving steps, saving money, keeping the cost down, staying competitive.
That's great. So this is the very first step. You start with the box and you go from there.
You got it.
Wow, that's great. All right, Bill, what are we looking at here?
Okay, what we're building right now is heat pumps.
Right.
A heat pump is a unit that'll heat or cool with the refrigerant system. This is a reversing valve. It's a very precise instrument that switches the flow of the refrigerant to cool one way, heat the other way.
Okay.
It's very important for quality when you braze the tubing into the reversing valve that you protect this valve. So we enclose it in a chill block, which is an aluminum fixture that circulates cold water through. So while we're brazing these tubes, the service valve
is completely
is protected.
Right. That's great.
Yep. Okay, Mark, let me start off by showing you the computer screen, and you can see the barcode scanning operator. That's part of a system we call critical component scanning. Every critical component that goes into our product gets scanned. The scanning is tied to the proper bill of material. When she scans the serial number and the compressor, it tells her two things. One, it tells her that compressor is the right one to go in the unit.
Right, that's
very important. Very important. The other is we have traceability. We have the serial number of that compressor tied to the serial number of our unit. You notice we have online printing of the serial plate.
Sure.
Just in time. That's part of lean manufacturing.
Great. What do we have here?
So the next step, this is where the refrigeration system starts. This is the evaporator coil, condenser coil, compressor, and you're seeing him attach the interconnected tubing.
Right.
In the cooling mode, the evaporator coil is cold, so it cools the inside of the room. In the heating mode, the evaporator coil is warm and heats the inside of the room. You can see all of the fixtures. Remember the tubing that was made on the first step?
Sure.
They're all put in fixtures so the tubes fit just the way they're supposed to fit. A couple things I want to show you here, Mark. This is the indoor blower. It's a tangential wheel blower with the wide vanes. It makes very little noise. What's the biggest disturbance you have in a hotel room? The noise of a PTAC, right? We want to think we've got the quietest PTAC in the industry because of that design. You might have also noticed she's installing an electric heater.
Right.
In a heat pump, when it gets too cold outside, you can't bring heat in from outside.
Sure.
So at about 30 degrees, the control board in the PTAC cuts off the compressor and goes to electric heat. Automatically. You don't have to do anything about it.
Well, that's good.
And the last thing I want to show you is the torque to attach this blower motor for that fan is critical. You see this gun here?
Oh, that's fancy.
This is not just a regular gun. This is a gun that is hooked to a computer with a computer screen up over there. We record all the torque values. If that torque value is not where it should be, that screen would go red, and we knew we would not have the adequate torque on the unit.
Wow.
Quality, very important. Technology's helping us on quality.
All right, Bill, well, it looks like we're surrounded by a lot of different color wires. Why don't you tell me what all these are for?
Well, we got wires, and as you see on the end of the table is the PC control board. That's the brains of the PTAC.
Okay.
Something I really want to highlight to you. See that wire?
Yeah, right.
We make these here.
All of them.
We make
All
all
the
of these
different
wires,
sizes.
all different. We buy all our wire with white insulation.
Uh-huh.
We have wire making machines that actually run this through an ink that colors it the right color, cuts it to the length it's supposed to be, and automatically puts terminals on the wire. Mark, once we get the refrigerant system all sealed up, all brazed up, something that's very critical to any product that's got a refrigeration system is cleaning the system out, putting a vacuum on it before we charge it. In order to do this on this high volume line, you see we've got a carousel of vacuum pumps. You see those vacuum pumps are hooked to the system, and they move along with the conveyor. They have to be hooked up to that unit long enough so that they can draw down a vacuum of 200 microns or better. Once the vacuum's drawn down, it's disconnected, and then it goes to the charge station, and we're getting close to being done, Mark.
All right.
Okay, what we've got here is a ready-to-run unit.
Wow, that's great.
This is the last operation. You see the computer screen over there?
Yes.
This operator provides the refrigerant charge to the unit. It's all done by computer. He scans the model number in. The computer determines exactly the number of ounces of refrigerant that goes into each unique model. It charges it, and then he uses this ultrasonic cutoff sealer that cuts off the copper process tube and actually welds it closed so we don't have a leak.
All in one step.
All in one step. Okay, we got a finished unit. Next we're going to go to the run test booth, and I'm going to show you how we run test every single unit we build.
Let's go see it.
All right, let's go. Now the run test is really what we're proud of. This computer behind you, you see this information here, it says pass, passed. When the unit comes in, the operator, again, error-proof. We don't use operators writing down serial numbers or keying in serial numbers. Use a barcode scanner. She's going to scan that unit. It's going to record the model number and serial number. And then she's going to plug it in and activate the run test. The run test is all done by computer, right? Both the computer in the PTAC and the computer here. The parameters that that unit has to perform at are preset by manufacturing engineering and product engineering, and they're all stored by a unique model number in the run test. So as it goes through this run test, if all the data going into that computer meets the parameters, if the right amount of current is being drawn when the compressor's on, if the right amount of current is being drawn when the fan's on, then it gets a passed run test. Every single unit has to go through a run test, and it has to get a passed run test record in the data file or it cannot ship. Mark, let me point out one last thing on run test. See this little card right here?
Yes, sir.
This is a customer response card. And every unit we build, on all our lines, but PTAC especially, we send this customer response card out.
Right.
And we really try to get our customers to send it back to you. Because I guarantee you, I read every single card that comes back into this plant.
Every single one.
Every single one, and I initial it. And then I circulate it through my manufacturing people, the product engineering people, because quite often we get input from our customers on how to improve our product.
So let me guess, in this room you completely test every single unit for leaks.
Hear that sound?
I do.
She's calibrating her leak tester, making sure that it will sense the refrigerant. And then on the other side, we test the condenser coil. On this side, we test the evaporator coil. Nothing is more detrimental to a product than a leak. And we even do one more inspection. We actually put a leak sniffer in the box in the warehouse before we ship them. But the real key is nothing's more important than having a good quality product. Okay, Mark, remember what I told you, critical component scanning.
Right.
And this young man's going to scan it.
Why does it scan it twice? What's the two different scans for?
Scans the first one, checks the screen, makes sure everything's okay. Scans the second one, confirms and prints. And out comes the label. The shipping label has all the information on the unit so that when it goes into the warehouse and the logistics system, it's got all the information it needs to know. This is the icing on the cake. That's the front panel that closes everything out, and that's what you see in your hotel room. This is the end of the line. It goes in the box here next.
All right, Bill, you got to tell me about this guy.
Okay. Those PTACs weigh about 150 pounds, right? Now, you imagine a couple of guys lifting those and stacking them up all day long.
Right.
Well, this guy never takes a break and makes the job more ergonomic. We don't have people straining their backs.
Looks effortless.
Very, very smart robot, though. See that stack?
Right.
Every one of those in that stack are the same model number because it's got a scanner on it that scans the model number.
Oh, okay.
Essentially, this robot is a unload robot. It unloads them and stacks them in an 8-pack, stacks them in like model numbers, and then from this point, a forklift comes and picks them up, takes them onto the warehouse, and then they're off to the customer.
Where are we going next?
Okay, we're going to go look and see where some of the components that are made that go into my PTAC are made here in this factory. We make our plastic front out of a 2-piece mold. We make the front door, we make the grills, we make the fan shrouds that hold the motor and fan. We essentially make, other than the 2 filters that go into it, we make every plastic part we use. But most importantly, I can control the quality of the products coming into me because I make them myself.
Outstanding.
Next step is we're going to go see where the fundamental part of heat transfer, the coils, are made that go into all our products. This is one of our coil shops. This is the fundamental module of heat transfer in our products is the coil. Start with a roll of aluminum that goes into that fin press. It's only 4/1000ths of an inch thick.
Wow, that's thin.
That's very thin, but it has to be thin so it's effective at heat transfer.
Sure.
The fin press makes the fins. After the fins are made, they're laid out on a table, and then they go through an expander.
Right.
The expander is a machine that runs little bullets, we call them, through the copper that expands that copper to make mechanical contact with the aluminum so that the transfer of heat from the refrigerant inside the tube goes into the air.
Bill, thanks for the tour. And again, sorry I was a bit late this morning, but that Amana Ptac in my hotel room just provided outstanding comfort.
You don't know how glad I am to hear you say that. Thank you.
Sure. Thanks again.
Thank you.
This has been quite a tour. But earlier we mentioned the energy savings associated with Amana brand Ptacs. So for the full story, we're going to head back to the hotel. Okay, joining me now is Tom Guffey, Vice President of Sales for Amana brand Ptacs. Hi, Tom. How are you?
Nice to meet you.
Nice to meet you, too.
Appreciate you taking the time with us.
Absolutely. I understand that you are the man who can tell me all I want to know about Amana brand Ptacs.
We'll certainly try. About 6 years ago, we designed what we call today the Amana DigiSmart control package for the PTAC unit. And what we've done is build into it the smarts in the system to control energy management and room comfort for the guest.
Tell you what, can we take a little bit closer look at the components and the controls?
Absolutely. The controls of the PTAC actually start with the control board on the unit itself. What we've designed is a very user-friendly interface, a touchpad as it were, with very few buttons on it, very simplistic, large fonts, colors that coordinate. The cool key is blue, the heat key is red, etc. And we've got a very large, bright LED display. The LED allows us to really make it very easy for people to see what the unit is doing and how it's running and functioning. Okay, this is the heart of the DigiSmart system. The control board you can just see partially exposed on the bottom. What we've done is we have an antenna that we can mount physically in the unit. It's a very simple operation, a couple of screws, and it actually plugs into the control board. And this allows us to gather all of the data from the unit and put it out to this antenna router and be able to broadcast that out to the platform. Or also, this is the device that is an RF wireless radio frequency device that is communicating with the occupancy sensor or the wireless thermostat, as well as then communicating through other antenna routers just like this on the other PTAC units throughout the building up to the platform. And then that platform, again with internet access, allows you to get all of the data from all of the units, both the peripheral devices in the room as well as the PTAC data that's stored on the control board, and then make the decisions and crunch the data and give that information out to the owner of the hotel, the maintenance engineer, the manager, again, whatever level that needs to be done. And a lot of that can be done either through internet access, again, security controlled internet access, or we can actually generate and send out email reports on the status of all of the devices. This is the Amana DigiSmart occupancy sensor. It's actually a dual function device. We have a magnetic switch on the bottom. When the door is closed, we know that the door is closed because the magnet is actually closing a switch in the bottom of the device. And when the door opens and closes, then we're able to know that we've had a door event that allows us or triggers us to look for motion. And then this is a passive infrared device that's looking for motion in the room. And how it works is when we don't see motion after 5 minutes, then we're able to declare the room unoccupied and do temperature setbacks at that point. When the room is occupied, once it's declared occupied, it stays occupied until we have another door event. So that allows you to not have the room guest be uncomfortable in the room in the middle of the night. This is the Amana wireless thermostat, and this is communicating to the unit via radio frequency wireless transmission. And you have full functionality control of the unit, mode, heating, cooling, etc., fan speed, and up and down arrows for temperature setting on whatever the room guest would desire the room to be. It has a backlight in it, and we also added a secondary passive infrared motion detector just in case in some of the more non-traditional room configurations we're able to pick up a second point of motion to make sure that when the room is occupied that we absolutely do not declare it unoccupied and inconvenience the guest by not allowing them to control the room atmosphere.
Well, I can tell you this unit was great last night for me. You know, it made me a little bit late this morning getting to the plant. Kept me really cool, and I was very comfortable in this room.
Great.
Hey, thanks, Tom.
Thank you again.
Really appreciate it.
Yes, sir.
Well, we've taken a quick tour of the Fayetteville facility today, but for a full exploration of the Amana brand of PTACs, you need to schedule a Dare to Compare tour today.